The solar system's 9 planets can be divided into 3 basic groups. The first group includes the 4 planets closest to the Sun, including Earth. We call these the inner planets, or Rockies, or the terrestrials. Terrestrial means Earth-like. Mercury, Venus, and Mars look somewhat like Earth. These 4 planets are small, have hard rock crusts, and dense rock and metal interiors. Heading away from the Sun, after Mars, there is a big gap of space before we meet the next group of 4 planets. This gap seems to take us into another world, because the planets beyond are so different from our own. They are giant spheres of gas, with swirling atmospheres thousands of miles or kilometers thick that gradually change into slushy oceans of frozen gases. There is no clear point where the atmosphere ends and the planet's surface begins, and it's even harder to find a solid surface on which to stand. Only if we sink deep enough, perhaps tens of thousands of miles or kilometers, might we find rock-hard surfaces that are not rock at all, but gases under intense cold and pressure. Only in the very heart of the planets, in the core, could we find familiar rock and metal. The 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, are strange places indeed. The third and last group of planets has a single member, Pluto. Pluto differs from the other planets in a number of ways. Why are the first 8 planets divided this way? Rocky planets close to the Sun and gas giants farther away. To find an explanation, let's look at how the solar system formed 4.5 billion years ago. The solar system developed from a huge cloud of space dust and gas called a nebula. The Sun started the process by condensing most of the nebula into a single sphere, like a giant raindrop in a storm cloud. The Sun claimed about 99% of the solar system's matter. Planets formed from the leftover bits of nebula. While the Sun grew, it pulled material in. But once it began to shine, the Sun also started gently pushing things away. This push came from waves of heat and tiny particles the Sun cast out. Dusts of rock and metal in the leftover nebula were little affected by the Sun's push because they were too heavy. Most gases, on the other hand, got pushed away. Far away from the Sun, the pull of the Sun's gravity equaled the push of the heat, and the gases floated like clouds in the sky while gradually forming the gas giant planets. The closest gas giant to us is Jupiter. Named for the Roman mythical king of the gods, Jupiter is the king of planets. It has more than twice the mass, or weight, of the other 8 planets combined. 1,400 Earths could fit inside. Seen through a telescope, Jupiter has striking brown and tan bands. The bands result from wind currents in the upper level of Jupiter's atmosphere. These currents resemble wind patterns in our own upper atmosphere on Earth. The winds are created by a complex process that occurs to air surrounding a rotating sphere. Jupiter's atmosphere also has an interesting place called the Great Red Spot. Located just south of the equator, the Great Red Spot is a gigantic hurricane covering an area about twice the size of Earth. This storm has been raging for centuries. With even a modest telescope, 4 of Jupiter's nearly 20 moons can be seen. The largest, Ganymede, is bigger than Mercury. Io is famous for active volcanoes. Despite its immense size, Jupiter rotates rapidly on its axis, once every 10 hours compared to Earth's 24 hours. However, Jupiter's journey around the Sun takes nearly 12 Earth years. All the gas giants rotate more rapidly than Earth, but take longer to orbit the Sun. Saturn, the next gas giant, has a 30 Earth-year orbit. Saturn presents one of the most striking sights in the solar system because it is surrounded by a magnificent set of colorful rings. From the inner to outer edge, the rings measure nearly 42,000 miles, or 70,000 kilometers across, but they are barely a half mile, or about a kilometer thick. The rings are made of dust and ice. Ring particles range in size from microscopic up to as big as a house. Astronomers are not sure how the rings developed. Perhaps they formed from materials left over from the planet, or maybe they contained the remains of an exploded or crushed moon. At least 20 other moons have been found so far within the rings. Included is Titan, second largest in the solar system after Jupiter's Ganymede. Of all the gas planets, Saturn is the least dense. Density measures weight per volume. For example, wood is much less dense than lead. With cubes of equal size, a wood cube will weigh much less than a lead one. Saturn is so light, it would take more than 5 bucketfuls to equal the weight of 1 bucketful of Earth, which is the solar system's most dense planet. In general, the small, hard, rocky planets are over 3 times denser than the gas giants. All planets, by the way, become denser towards their middle because the weight of material above packs everything tighter. Beautiful Saturn is the last gas giant people can see without strong telescopes. The next gas giant, Uranus, is half the diameter of Saturn and orbits twice as far from the Sun. It's so distant that turning on a flashlight for 1 second produces more light than Uranus has reflected to Earth during the past 2 centuries. Uranus seems to lay on its side. Its axis tilts 98 degrees compared to the Earth's 23.5 degrees. Some astronomers wonder if Uranus was knocked over by a collision with an asteroid. As Uranus makes its 84-year orbit, the pole closest to the Sun is bathed in daylight for 42 years. Then it gradually turns away from the Sun and into darkness for the next 42 years. Uranus shows a temperature pattern typical of gas giants. The upper atmosphere is very cold, not much warmer than deep space because the Sun's rays are so weak at this distance. Deeper down, temperatures increase, mainly because of pressure. The pressure comes from the weight of material above. Pressure forces molecules and atoms closer together where they rub each other, creating heat, like sticks rubbed together to make a fire. Inside temperatures may reach several thousand degrees. The core, like those of other gas giants, is probably rock and metal that is molten or melted. The rock and metal settled out from the small amount of dust that remained in the planet's original gas clouds. Like most planets, including Earth, Uranus has a magnetic field surrounding it. The field is generated inside the planet, where certain layers rotate at different speeds. This creates magnetism in somewhat the same way that an electric motor does. Interestingly, Uranus's magnetic poles are tilted 60 degrees from its geographic poles. Earth's magnetic poles are only 11 degrees different. The last of the gas planets, Neptune, appears to be a twin of Uranus, though its axis still stands upright. Neptune probably has a similar small rock and metal core, which is surrounded by various gases in ice form that gradually give way to dense atmospheric clouds of hydrogen and helium. Like other gas planets, it spins rapidly on its axis, but leisurely orbits the Sun, once every 165 years. Neptune and Uranus perform an interesting orbital ballet. As Uranus approaches Neptune, Uranus speeds up. Neptune's gravity helps pull it along faster. Similarly, after Uranus goes by, it is slowed down by drag from Neptune's gravity. Astronomers say Uranus's orbit is perturbed by Neptune's. To some degree, every planet perturbs the orbit of all others. Perturbance is caused by gravity, and the laws of gravity say that the gravitational pull of every object affects all other objects in the universe. However, as a practical matter, the effect is often far too small for us to measure. Recent satellite visits have helped provide significant information about Neptune. However, at nearly 2.7 billion miles, or 4.5 billion kilometers from the Sun, the planet orbits in near darkness and remains much a mystery. Beyond Neptune is the final known planet of the solar system, Pluto. Pluto little resembles the gas giants. It is tiny, lacks an atmosphere, and has a hard rock and ice surface. We are not sure where Pluto came from or why it's there. In a way, though, we may actually understand Pluto better than the gas giants. The endless depths of swirling gases and slushy ice that make up Jupiter, Saturn, Uranus, and Neptune are so different from the hard surfaces we know on Earth. The gas giants could easily be science fiction if they weren't real.